Hey, what's up, my Form 5? Welcome back to our weekly lesson. This week, more calculations, alright? Don't be scared yet because this part will be very simple, I swear. Okay, we have two more formulas remaining. Okay, just refresh a little bit. Last week, we learned about inertia, and then we learned about ticker tape. Just remember the strip of tape we cut, and then we don't count the first dot, we don't count the first strip. Remember what is calculation, what is acceleration and velocity. Okay, if you don't, refer it back. Okay, it's not related to this week. Even if you don't understand last week, you can definitely understand this week. All right, this week we are going to learn about momentum. Okay, so what is momentum? Anything that moves has momentum. Okay, this is something related to inertia. Okay, so inertia. Okay, inertia, whether you are at rest or you are moving, you have inertia. Like remember, things at rest, moving things stay moving, you have inertia. But for momentum, if you are at rest, your momentum is zero. If you are moving, you have momentum. Okay, so if let's say I'm moving, I'm running very fast, I have inertia and I have momentum. I hope this makes sense. All right, so what is momentum? Momentum is the product of mass and velocity. Okay, which means mass times velocity. Remember what is velocity? Which is speed lah. Okay, so mass times velocity is momentum. So the heavier my object is, the higher the momentum. A lorry has more momentum than a car. Okay, same goes to your inertia. Okay, and then velocity, the higher the velocity, the higher the momentum. A faster car has higher momentum compared to a slower car. Okay, so if you look at inertia, only mass is affecting inertia, but for momentum, mass and velocity will affect in momentum. This is why they are slightly different. Okay, because let's say when you're not moving, velocity is zero, momentum is zero. Okay, but for inertia, inertia will never be zero. As long as you have mass, you have inertia. Okay, so the unit, okay, unit very simple. Mass is kg, velocity is ms minus 1, so you just put them together. Kg ms minus 1. Okay, or Newton second, okay, not important. Okay, so the bigger the mass and velocity, the bigger its momentum, like I said just now. Heavier object, higher momentum. Faster object, higher momentum. Okay, so let's look at the example. The mass of a car with mass of 1005 kg move with velocity of 20. What's the momentum? So 1500 times 20, you get 30,000 kg ms minus 1. That's all. Okay, so I want to talk about the next point. This point is very important, which is the conservation of momentum. Okay, what does it mean by conserve? Conserve means before and after is the same. Okay, let's say I bring 5 ringgit to school. I come home with 5 ringgit. My money is conserved. I didn't spend any. Okay, I maintain my money, which means conserve. Okay, what does it mean by momentum? Conservation of momentum means a total amount of momentum before collision. Okay, let's say now let's say two cars going to collide, going to crash into each other. Before crashing and after crashing, momentum will be the same. Okay, that is provided with one condition. You must have one condition, which is a closed system. What does it mean by closed system? Closed system means no energy loss. No energy or momentum loss. To where? To surrounding. Okay, that is assuming perfect world lah. Okay, this is not possible in real world, but for easier calculation, we just assume everything is closed system. Okay, so the principle of conservation of momentum says that before collision and after collision, momentum is the same. Okay, which means, okay, let's say before collision here, A has momentum, B has momentum, so A plus B here is equal to after collision. So now you see after collision they stick together, so the momentum of A and B here would be the same as before. Let's say before collision is 30 momentum, after collision is also 30. This means the conservation of momentum. Okay, you may say how this applies to real life. It doesn't. Okay, unless you want to study more detail into it. Okay, we don't study about detail about this. Okay, so let's look at the example. Okay, trolley A is moving at a speed of 30. Yeah, before that, let's not talk about any detail. Okay, so A has 30, is it mention here, trolley B is static, which means velocity here is, okay, velocity is 0. Static means 0, okay, rest. After they collide, both trolley moves together at 15. So calculate the momentum before and after the collision. So before collision, what's the momentum for A? Okay, momentum for A is, I'll calculate here lah, 30 times 0.1 is 3. Okay, so 3 kg, this is for A. For B is 0.1 times 0. Okay, because the speed is 0, so 0 is 0 lah. So before collision is 3. Okay, this is before. So what about after? After, okay, two of them move together, we can just add the mass together, 0.2, okay, because they're moving together as one already, so 0.2 kg, okay, times 15, you should get 3. Okay, so can you see before collision is 3, after collision is also 3, okay? This is the conservation of momentum. Before is always same as after. Okay, so very simple concept. We'll talk about the exercise later. Okay, so very simple concept, momentum. This is something to do with movement and collision. Okay, next, let's talk about something unrelated. We talk about pressure. Okay, oh, this is a very interesting concept. So pressure is the force that acts on a unit of a surface area. So this is the formula. Force divided by area is pressure. Okay, so what's the unit? Okay, because force is Newton ma, area is meter square, so you bring the meter square up, you get nm minus 2, or you want a simple one, you just add Pascal. Okay, next time, okay, I think you're almost at age to drive already. Next time, if you put wind in your tire, okay, you pump wind in your tire at the petrol station, you look at the meter there. There's a unit that says this. Okay, it says kPa. Okay, K means kilo lah, like kilogram. Okay, so PA is the unit, Pascal. Okay, because pressure is found by someone called Pascal. Okay, Louis Pascal. Okay, so okay, let's talk about how do we apply this. Okay, let's assume force is constant. Force doesn't change. If area is high, pressure is low. Okay, I hope this makes sense. If you divide by a higher value, you get a smaller answer. Okay, let's say you imagine you divide by 1 and then you divide by 10. If you divide by 1, your answer is higher value. If you divide by 10, your answer is smaller value because it's divided by 10. Okay, so if I increase my area, I reduce my pressure. Okay, let's say now I wear sports shoes. Okay, compared to high heels, sports shoe has very broad surface area. That's why you see high area. If I step on you, you don't feel that much painful because the pressure is low, although it's the same force. Compared to, okay, if now I have lower area, I would have higher pressure. Like just now, I divide by 1, I would have higher answer. Okay, now imagine I wear high heels and I step on you. I am the same weight, that's why force is the same. But now you feel much more painful. Why? Because the area is smaller. That's why the pressure is higher. That's why you feel more painful. Okay, I hope this makes sense. So, large force, you have smaller surface. You have large. Let's don't assume the force here. So smaller surface, large pressure. Larger surface, small pressure. Okay. So where do we apply this? Okay, where do we apply high pressure? High pressure is when I want low area. You can write here. So when do we use low area? Number 1 is our knife. Okay, we need sharp knife. When we are sharpening our knife, we are making the area smaller. Okay, if the area is very broad, imagine a knife that is very blunt, very broad, you cannot cut anything because the pressure is very small. So you sharpen it, you make the area here smaller. That's why you can cut it through. Okay, and then of course your nails. Okay, the tip of your nail is very sharp. Okay, small area, high pressure. That's why when you hit with a hammer, it will go straight into anything you want to go in, like let's say wood. Okay, so low pressure, where do you use low pressure? Tires. Okay, for heavy vehicle. Okay, this is where I apply large area. Okay, why? Imagine now I have a lorry, I use small tire, very narrow tire, pressure will be very high. I will sink into the ground. Can you see mud around? Okay, for vehicles that are going through mud, I need very broad tire because I need to reduce my pressure so that I can stay on top of the road or whatever. Okay, so same as snowboard. Okay, one of it is snowshoe. Okay, snowshoe. Okay, you know a snowshoe, when you walk in snow, if you don't use snowshoe, you can just step right into the snow, and then it will be very hard to walk because the area of your foot is very small. So if you wear snowshoe is very big. Okay, it's like a shoe that has a big area. So now the area is bigger, the pressure is lower, you don't sink into the ground. Okay, I hope this makes sense. Very important concept here. Okay, so hydraulic system, I think I will talk about this next week. Okay, this is also also pressure. Okay, but this is the harder version of pressure. We use liquid pressure. Okay, so let's go into the exercise. Okay, let's go into the exercise. Nothing too difficult here. Okay, so diagram 6 shows an experiment to study collision between object of different mass with plasticine block. Okay, so there's a plasticine here, I think. Not very clear here. So x and y moves at velocity of 20. So 20 and 20. So what is the manipulated variable? That is the mass of trolley. Can you see one is 2 kg, one is 1 kg? What is the responding variable? Can you see the plasticine here? Why are they the same depth? This one should be deeper because higher mass, higher momentum. I can crash deeper into the plasticine. That's why if you have higher momentum, you crash into the wall, more likely you are going to die. Okay, because you have high momentum. Okay, that's why driving fast kills you, because of the momentum. Okay, so responding variable is the, let's just say dent lah. Okay, dent, not dent, depth of dent on plasticine. Okay, means how deep is the groove. Okay, control variables, constant variable, what do you don't change should be your velocity. Okay, velocity of trolley. Okay, both I put it at 20 because if this one I put 10 and 10, then I have 2 MV already. Okay, manipulated variable, we can't have that. We can only control one thing. Okay, so or you can even say the surface of, okay, surface of trolley, okay, which is this. What are they running on? They should be the same surface because friction will change it. State one observation. Okay, so 2 kg trolley produces deeper dent. Okay, state one inference. Why? Because 2 kg trolley has higher momentum. Okay, heavier, higher momentum, the dent is deeper. It's like a very slow car crash into your car has only a small dent, but if a very fast car crash into your car is like a big dent there. Okay, so state the hypothesis. The higher the mass, okay, the higher the momentum. All right, simple. Okay, so same concept as just now. This car is 1002 kg. Okay, traveling at 30. Okay, head-on collision with a 3000 kg lorry at 10. Okay, after the collision, they are stuck together and they move together. Okay, what is momentum? Momentum is a product of mass and velocity. Okay, so what is the conservation of momentum? Okay, momentum before collision is equal to the momentum after collision. Alright, I'm not going to write the full one, you just write the full one in your exam. Okay, so determine the momentum of the car before collision. Okay, so the car, so momentum stands with P lah, P equals to, or you can don't write P, never mind. Okay, so 1002 times 30, you should get 36,000 kgms minus 1. Okay, how about the lorry? Lorry is 3000 times 10, because the lorry is moving at 10, so should get 30,000 kgms minus 1. Okay, so this is the total momentum. So total momentum of car and lorry after collision. Okay, Do you add them together? Do you add them together? The answer is actually 36,000 minus 30,000 equals to 6,000. Okay, here's a very good question. Why? Can you see one is moving left, one is moving right? Okay, you have to minus them. If they are moving the same direction, they can add together. But now they cancel out each other. Can you imagine 10 momentum and 10 momentum? They crash together, poof, they will cancel each other out. So the momentum is 0. Okay, so the momentum is 0. So you have to consider the direction here. Okay, so common velocity after collision. So what's the total weight here? Is 1,002 plus 3,000. Okay, so now I have my momentum. Okay, momentum doesn't change. Before collision is 6,000. After collision is still 6,000 because this is the conservation of momentum. So 6,000 equals to what's my mass just now? 1,002 plus 3,000 times velocity. Okay, so my velocity, this one plus this one is 4,200. You should get 6,000 divided by 4,200. Okay, 60 divided by 42. Okay, you can just calculate it yourself. Okay, let me do it real quick here. 60 divided by 42. Okay, 1.43. So that is 1.43 meter per second. All right, so make sure you don't add them together. Okay, what happens if you careless mistake you add them together? This would be 66,000, and if you put it here, 66,000 divided by 42, okay, 4,200, you will get a stupid huge amount. Means two car crash together and then they'll go even faster. Okay, that doesn't make sense. That would be like so stupid already. Okay, so make sure you consider your direction. Okay, so for the lorry, the momentum is actually negative. Okay, I didn't talk about this here. Okay, not very important, but good to know. A very fast car and a very fast car, they crash together, they will cancel each other out. It's not like they will add the momentum together. I hope this makes sense. All right, so let's talk about pressure here. Okay, so what's the experiment here? Can you see this one area is very small, so this one area is very big, so this pressure area small pressure is large. This one area is large, pressure is low. So which one will sink? The one with the high pressure. Okay, P will sink to the ground. This one won't sink. Okay, like I said just now, you wear normal shoe and when you wear snowshoe. Okay, can you see? So what is the aim of the experiment? To study the relationship. Okay, always write your aim like this. Okay, this is the formula to study the relationship between your MV and RV. This is the formula for aim. So what's my MV here? My MV here is the base area. Okay, base area. RV here is the pressure. Okay, so what's my MV here? MV is my base area of wooden blocks. Okay, responding is the depth of wooden block. Okay, depth of plasticine, sorry, because I want to see how deep is the plasticine. Okay, what I don't change? Constant variable, I cannot change the weight. Can you see? 100 gram, 100 gram. Okay, so weight on wooden block. Okay, because if I change this, then it will I will give different result already. So draw a conclusion. Okay, the higher the base area, okay, the lower the pressure. Okay, simple concept. Okay, same concept here. Can you see area big, area small? Objects are allowed to fall on the plasticine. What observations do you make? Okay, X produces shallower dent compared to Y. Okay, what inference can you make? Okay, base area of X is larger than Y, So pressure of X is smaller than Y. Okay, beside mass, what other factor must be kept constant? Okay, so beside keeping the mass constant, what else can you keep constant? The height of copper cylinder. Okay, because one, if I put very low, one I put very high, of course the dent is going to create different size. Okay, so they must be released at the same height. Okay, so each copper cylinder measure 10 times 2 times 2, which means, okay, I draw the block out, okay, which means 2 times 2 times 10, okay, has density of 9. Okay, what is the volume and mass of each cylinder? So what's the volume? So mass, very simple to calculate here. Let's calculate the volume first. Okay, volume is 10 times 2 times 2. Okay, you should get 40 cm cube. Okay, so if you still remember, density is mass divided by volume. Okay, this is form 1 stuff, don't forget. So how do you calculate mass? You times density and volume lah. So what's the density? Density is 9, volume is 40. You should get 360 gram, because gram here. Okay, so calculate the pressure of exerts on each plasticine. So what is formula of pressure just now? Pressure is force divided by area. Okay, it's already given in the formula. Okay, so 1 kg is 10 Newton. Just now how many kg here? So this is 0.36 kg, convert yourself. So 0.36 kg equals to 3.6 Newton. Okay, so both K's are 3.6 Newton because they are the same cylinder. Okay, but for X, I'm using this area. So 3.6 divided by, what's the area? If I'm using this area, okay, I'll draw another one here. Okay, for cylinder X, I'm using this area. So what's this area? This area is 10 times 2, which means 20. So I would get 0.18 Newton per cm square, because I'm using cm here. Okay, but for Y, okay, I hope this makes sense. But for Y, I'm only using this area. Can you see the area is smaller? So same case here, 3.6 divided by, this is 2 times 2, which is 4. So I would get 0.9 Newton cm. So can you see? This one, smaller pressure, because I'm having larger area. Although they are the same mass. This one, higher pressure. Okay, if let's say I throw my bottle at you like this, it's less painful than I throw at you like this. Area smaller, if it hits your face, it's going to be much more painful because the area is smaller. Okay, I hope this makes sense. All right, so same concept here. State 2 factors that affect pressure, which is your mass and area. Okay, and then physical quantity that cause the dent on the sponge. What causes the dent? Okay, pressure. Without using other materials, suggest a method to reduce the dent by H. How can you reduce the dent? Okay, you can increase. Oh, they don't want. Oh, okay, you can increase the surface area. Okay, increase the surface area. That's the only thing you can do, because they say you cannot change the material. Okay, so K, which car is more suitable to go into multi-track? Okay, car A. What's the difference between the two tire? Okay, the area of tire A is broader than B. Okay, relate different state in L to K. So how do you relate these two? Okay, the larger the area of tire, okay, the lower the pressure. Okay, two other applications that will reduce effect of pressure. Okay, when do you reduce your pressure? Okay, you don't want high pressure, is just not tire lor. Okay, snowshoe, okay, skateboard. Okay, what else? Increase pressure. When do we increase your pressure? Nails, okay, knife, okay, and so on. Okay, so I will stop here. Okay, next part will be hydraulic already. I'm not going to talk about this this week. We will talk about this next week. Okay, I hope this makes sense, especially the pressure part. That part is super, super important, okay, for you to understand next week. And of course, the pressure question is very common in exam. Okay, I hope you understand what I talked about this week. If you don't, please post any questions you have down there. Okay, so I'll see you again next week, and goodbye.